So, start number 1. You'll need your calculators out. I don't have mine on me.
You want one?
No, you can just type it in. So,
We've done number 1 already. You want mine? Yeah, sure.
I have to. That's what I'm saying.
well, I've done number 1, but what I'd like to do, it's very easy for me to do a new lesson, and you know, we could be working on something, or you could be listening to me doing questions for 50 minutes. Which would you prefer? Prefer listening to me? Then don't talk. Okay, I know we did number 1, but I feel like I should do all 8 of them, because then there's one video lesson for all the answers.
Yes.
It'll make it easier for your revision. Okay, so number 1, we can do it quick. I tell you the temperature equals 27 plus K e to the minus 0.2 T. And I tell you initially, or I didn't fix that, sorry. Initially the temperature is 65. So that means at the beginning, the temperature is 65 when T equals 0. So I get 65 equals 27 plus K e power 0. And that's great because e power 0 is 1. So you get K equals 38. Is that right? So now we have a new formula, or a complete formula. Temperature equals 27 degrees plus 38 degrees times e to the power of minus 0.2 T. Okay, so that answers definitely the first part. Now time for the second part. When is the temperature 35? So in other words, temperature is 35, find the time. So 35 equals 27 plus 38 e to the minus 0.2 T. Now take the 27 over to the left, and that's 8. And then we'll do 8 divide 38. So I get 0.2105 equals e to the power of minus 0.2 T. Nearly there. Natural log on both sides now. Natural log and exponential cancel. So on the right I have minus 0.2 T, and on the left I'll have minus 1.558. Now divide that by minus 0.2 and I get 7.79, but I ask you to round it to the nearest minute. So T equals 8 minutes. These are in minutes, aren't they? Yeah. Yes.
I need to go now.
Okay, that's fine. Right, immigration, is it? Or where are you going?
Yeah.
Yeah, there's some students have to go to immigration today with Sylvia, isn't that right?
Yeah, she's calling me right now.
Right. Anyone else needs to go to immigration with Sylvia? No. No, please, don't confuse my question. I just want to know if you need to go to immigration. If you need to give something to Sylvia, if you need to talk to Sylvia, have a cup of tea with Sylvia. This is all after maths class. Does anyone need to go to immigration now with Sylvia? Just Sadiq, yes? Well, Sylvia's going to immigration. She might even be at immigration now. Go see her now quickly, because I have a feeling she'll be going very soon. Right, okay, number 2 now. No, listening time. Number 2 now. So this one we haven't done. A bank account grows over the course of a year. The growth model is that. So in other words, if you put money into the bank, I know it's not true for everybody's home country, But in the West anyways, if you put money into the bank, like savings, and you leave it in the bank will pay you a little bit of interest each month or each year for leaving the money on deposit. I don't know if everybody understands this, okay? I know for some people in their home country, banks don't do this. But anyways, that's called interest. You leave your money in the bank and it grows slowly, okay? And in fact, the growth is exponential growth. So I suggest in the question that your bank balance equals AEKT. And we would like to find the constants A and K. I tell you that at the start of the year, your bank balance is £100, and at the end of the year, your bank balance is £103. So at the beginning, you have £100 on deposit. That's when T is 0. And then after 1 year, you have £103 on deposit. Let me get some more paper here. Well, the first one is always great because the 0 really simplifies things. If I put the first one in, I get 100 equals A e to the power of 0. So what's the A? £100. Now I need to put this one in. Okay, so what's the B? The balance is 103. What's the A? 100. And what's the T? 1. So it's just K here. Now, again dividing by 100, so I get 1.03 equals e to the K. And then what's next? Natural log. So I get K equals 0.029558, so 56 I'll say. Right, so we have now your balance will equal A e to the K T. So that's part 1, find the A and the key, the A and the K. And then, yes? T is time. Oh, sorry, I wrote in days. Well, that's okay. I just did mine in years. So it just means for the next one, I'll have to do it in years rather than days. Sorry about that. The question said use T in days. So instead of 1 here, what would I have? 365, okay? But it's okay, I'll leave it in years. I just need to make a change for the next part. They want to know after another half a year, what will the bank balance be? So if you were doing it in days, the T would have to, you have to divide 365 by 2. But now, if I'm doing it in years, it'd be 1.5. It'd be the original 1 year plus an extra half a year. Okay, so the T will be 1.5, 1.5 years, instead of whatever it would have been in days. So in the second part,
Just keep it as we're doing it.
we're keeping it as years, yeah. In part B, 2B, so we want the balance after 1.5 years. And then here is 1.5. Okay. So I got this on my calculator as £104.53, which is right at the back here. Okay. 3A, we did this yesterday. So what you have is a town at the start of the year when T is 0 consumes 12 megawatts a day. And then at the end of the year, it consumes 13 megawatts. And the question is find a formula for the amount of energy consumed by the town at a particular time. So like in the previous question, we assume it would be exponential. Okay? So just like before, I put the first one in and I get 12 equals a e to the power of 0. So what's a? 12. Do you notice some pattern here about what a will be? A is always looking like it's what? In general. Yeah? It always looks like it's the term at the beginning, doesn't it? And that's actually true. Okay? Now I put in the second one. So I get 13 equals a e b, which is times t, which is 1. So like before, I divide by 12. And I'll take the log. So I'll get here b equals 0.08.
So that's 8. Oh, you put it, okay.
Now, if I just go down a bit. Oops, don't worry, it's still there. I have my answer. Energy will equal A, E, B, T. So that's part A.
How did you get 0.08?
Well, I kind of skipped it here. I divided by 12 and I took the log.
Oh, okay, so.
Because it's the same as the other ones, yeah? Okay. Now, we know that that makes a nice exponential graph like this. And there's our 2 points on the graph. But in the second part I say, okay, well what if it was a linear growth? What equation would that be? So we have our 2 points. The first point is 0, 12. And the second point is 1, 13. So first I get the m. y2 minus y1 over x2 minus x1. So what's the m? 1. And then you get the c. But if you remember, c is where it intersects the y-axis. And what's the height here? 12. And here? 13. And here is 0 and here is 1. So the c is 12. So you very quickly get E equals t times 1 plus 12. mx plus c. The last part is I ask you to calculate the difference between the two models at the end of the next year. So in other words, here when t is 2, and here when t is 2, how much energy is predicted by each model. So if I put the linear one first, the linear model, when I put t is 2, what's the energy? 2 plus 12? 14 megawatts a day. Now if I go back up to the top of the page and put t is 2, yeah, I got something close. This is the exponential model. 14.08 and all the trees then. So you can see that the difference is 0.08 megawatts a day. And which do you think is the more realistic model? The exponential one. Although just a warning perhaps, the exponential model would be most accurate when the town is growing. But when the town starts to reach its kind of capacity, its limit, then the linear model would be more accurate. You do this like in biology. You know, bacteria will grow exponentially at the beginning, but what happens when the food starts to become scarce? Then the bacteria can't grow as fast, so then a linear model would be more appropriate. Okay? Right, so that's 3 taken care of now. It's good for you to know this because sometimes there might be a question in the exam worth 1 mark where they would say, comment on the difference. Okay? And really, I can easily give you the mark once you make some sensible comment. Okay? So even if your comment was, I think the exponential model is more accurate because the growth should be exponential, I'll give you 1 mark. If you said, I think the linear model should be more accurate because I believe the growth to be linear, I'd also give you a mark. I just need you to make some sensible comment at the end to show that you understand what's going on, if they ask it in the exam. They don't ask it too much and it's only 1 mark. But don't leave it blank is my point. Okay, it's easy to get a mark for, writing a sentence that makes sense. You can all do this, right? Yeah? All right, okay. 4 now. Now there's a term here that you might probably have not heard before, so I think you should underline it in the question. It's the 12% APR converted monthly.
These are business questions.
Well, you see, this is the thing. The semester 1 exam is for both sets of students, so the questions could be business or science related. Well, it's good to have some business sense, Does anybody know what APR means? I don't want what it stands for, just like what does it mean? What is it referring to? APR means the interest per year. So write in per year if you didn't know that. So 12% APR means you pay 12% or 12% is paid per year. In Ireland and other countries, when a bank is quoting its interest rate, it must do it on a yearly basis, okay? So it should say what percent per year, and this is called APR. However, banks don't have to pay interest per year. They can pay interest whenever they want. For example, my bank pays interest every month. Some banks pay interest once a year. Some banks pay interest every 4 months, okay? The term converted monthly means this bank pays interest each month. Okay? So write down beside converted monthly means each month.
But you told us APR is per year.
Yeah. So because the bank has to say its interest rate per year, but then it can specify after that how often it pays the interest. So 12% APR means it's 12% per year, and then converted monthly means but it pays the interest each month. And it really is as simple as dividing by 12 to work out how much that is per month. So if it says 12% a year, but it pays it each month, then how much is it per month? It is 1%. Okay, that's how it works for these things with banks. So 12% APR converted monthly is a fancy way of saying 1% a month. So this equals 1% per month. That's important. That means my time should be in months, okay? So T1 is 1 month, T2 is 2 months, T3 is 3 months. Okay. Now, what model should I make for bank balance? What type of model? I give you a clue. It's everything we're doing today. So what model do you think would accurately represent bank balance growth?
The one we just did before.
Yes, exponential. Interesting that, isn't it? So it's going to be exponential. But the slight problem here is I don't have numbers, do I? But it's actually, for this type of problem, it's okay to put in some numbers as an example to calculate the constants A and B, okay? If you don't want to do that, you can just use letters like X, Y, whatever. So for example, What letter could we represent for the money that she puts in at the start? Any letter really. So we can call it S, X, whatever. So when T equals 0, let's say the balance equals X, for example. Okay. Now, when is her first interest payment? After 1 month. So when T equals 1, what does B equal? Now, 1% extra on the X. So it'd be X plus, now there's other ways of doing it, yeah, I think, what was the other way, Brendan? You could say, yeah, you could say multiply by 1.01, but I often find each year that this confuses people. So anyways, it's X plus 1% of X. How do you get 1% of a number?
X over 100?
Yeah. Right? To get 1% of a number, you divide by 100. Now, let's clean this up a little bit. This will equal 1 plus 1 over 100. And if you type in on your calculator 1 plus 1 over 100, you'll get 1.01x. Yep, oh, I know it's correct, yeah? I have no doubt of that. Okay, now let's just put into our model. So, bank balance equals AEKT. Let's take a shortcut here. We know what the A is going to be. What's it going to be? What's it going to be? X. Because that's what's first, yeah. Alright, now let's calculate the K here. So after 1 month, what's the T? 1. And what's the T? 1 multiply K? Okay. And what's the B here after 1 month? 1.01x. And you can see actually the x was not important because they cancel. So, log 1.01 0.00995. Is that right, yeah? Okay. So now we have bank balance equals x e to the power of 0.00995t. Now we can answer the question. We want to know, when does she double her money? When does her money double? So what does the B equal? Yeah, what is it? 2 multiply x. She wants to know, when will her money double? How much does she have at the start? X. So she wants to know when she'll have 2x. X's cancel. And then you have log 2 equals 0.00995t. So if you round it to the nearest month, you get t equals 70 months as the answer. Yes, which I round at the back. Yep. Okay, go down a bit. I had to make a correction to number 5. Remember I said the minus wasn't there. And then after talking to Lorraine, I realised I made another mistake. It's not base E for pH level. You can see how I changed the base? Base 10. But you say this as if you knew it. So why didn't you say anything the last time?
Because I wasn't sure
have more confidence, okay? So base 10, which doesn't really change things too much, okay? So, can I go to the next one now? pH level equals minus log base 10, the concentration of these hydrogen ions. Now, I basically want to know what is this concentration level if the pH level is 3.5. So I have 3.5 equals minus log 10. Let me make my life easy by just calling this X rather than this symbol here. I'll take the minus to the left. Now, think back, the definition of log is 10 to this power equals X. So 10 to the power of minus 3.5 equals X, which will equal 0.0003. That's why there seemed to be an extra 0 yesterday. What's the unit, by the way? It's moles per litre. Have you done moles in chemistry?
Yeah.
What's the letter for moles? Big M or small M?
Small ones. Moles as if like the number of moles.
Wait, moles per liter is
It's the mole.
ML.
This is moles per litre, right?
It's like molar.
No, hang on. Wait.
And it's small M.
It's a molar volume.
Wait, Avenue, just wait. Moles per litre. Do I use big M or small M?
No, small M. Okay.
Small M, but I think if you want moles per litre, big M represents that
Molar.
for short, right? Is that right?
Yeah.
This is like, what's it called? Molar density or something? Or molarity or what is it?
Volume.
Lorraine would be so delighted.
Just put moles per liter.
Yeah.
That's better.
Now, I think we're all agreed that this is suitable, yes? All right. Okay, so write that down, please, and now we'll do number 6. I do remember, though, the big M is different to the small m. The big M is like moles per litre, isn't it? Or isn't it
No,
like
you
this?
have to put the L per liter.
Can you remind me? You get the 10 over.
Well, that's the definition of log. Log means base to this power equals the argument. Okay, 6 now. So, loudness, decibels, how loud something is equal to log base 10, the intensity, and we did intensity in physics, by the way, but if for non-physics people, intensity just is really how much energy, divided by this constant, I0. Okay? And the question is, if a gun is 134 decibels, what's the I? Okay, so the decibel level is 134. The I is what you want, and the I0 is 10 to the minus 12. Okay. I think the difference between this and the pH question is you need a bit of cleaning up here first. So you got 134 equals log base 10I minus log base 1010 minus 12. So I got 134 equals log base 10I plus 12. Now can you see how I got the plus 12? That minus 12 comes down in the front to make minus 12. And then what's log 1010? 1. So that's how I got the plus 12 there. Taking that over to the left, I got 122 equals log 10I So then I is 10 to the power of 122.
It's minus 12.
Yeah, it's minus 12 here, right?
Yeah.
And then it comes down with the other minus there.
Oh,
Right? Yeah. It is minus, isn't it? Yeah.
Log base 10 is like 10. Is it 1? Isn't it 1?
Mm-hmm.
So why is it not 13?
There's like a 1 here. Multiply 1.
Oh, how much?
120. Whoa, that's too big for the calculator. Can anybody type this in on the calculator and get an answer?
No, we'll just get a math. It doesn't even simplify it.
No. Alright, I've made the numbers way too big. So we'll just have to leave it there, okay?
it's 10 to the power of 122, right?
Okay. What's wrong? No. Yeah, I made that number too big.
It's not actually related to the topic. Can you do this? How do you do this?
Later. I'm in the middle of this one. If there's time at the end, I'll do it. Okay, right, sorry, so I made the numbers too big for that, so you'll just have to leave the answer like that. I have a feeling the problem is I didn't put in a decimal point. Okay. 7 now. Now, in number 7, have you done carbon 14 in chemistry?
You know of it, yeah.
You know of it, okay, alright. So, carbon 14 has a half-life of 5730 years. Does anybody know what that means? It means if you start at 100% at the beginning, after this much time, how much do you have left? 50%. So the level of carbon 14 equals, what type of model do you think we'll use here? Go on, don't be shy. Exponential, which is A e to the bt. Now, what is the A going to be here? Come on, no talking. I want to hear what the A is going to be. Someone tell me. 100%. Now let's put in our second line to get the B. So this will be 50% equals 100% E B, and what's the time? 5730. Now divide by 100. Yes? And then what do I do next?
Log.
Log. So log 0.5 and then divide by 5730 and you works out as B equals minus 0.0001296. I'll say 121 like that. Now we have our formula. The amount of carbon 14 left in something would be 100% times e to the minus 0.000121 t. In this question here, I tell you, you find something here, Dead Sea Scrolls, they have 79.5% of their carbon-14 left, and I want to know how old they are. Okay? Right, so I'll just do that. So here is 79.5 equals 100 e to the minus 0.000121 t. So dividing by 100, and then we need to do log of both sides. So I get log of that equals that.
What did you do?
I divided both sides, I brought the 100 down,
Oh,
and then I took log of both sides. I did two things in one step. No, I've lost what I was doing here. Right, okay. So then the t is approximately 1,000, to the nearest 100 year, it's 1,900 years old. Okay. Now what I'm going to do is for the last, I really want to leave one for you to try to do actually. For the last 5 minutes, you could try, everybody could try by themselves number 8. Okay, but before you do that, let me just fix the numbers in number 6, okay? So in number 6, could you change the 134 into 13.4? Have you done that? Come on. In number 6, do you see where it says 134? Can you change that into 13.4? Yes? And I just need to fix the vocabulary. Do you see where every time you see the word, see where it says decibel dB?
yeah.
Just delete the D there. So it just says B. And you see at the end where it says dB again?
Yeah.
Just delete the D. So it should read now loud, and you see where it says decibels at the start?
Cancel.
Change it into bells. Okay, so if you did that question again except using the number 13.4, I think that would be small enough for your calculator. Okay? Alright, so if you can all try number 8 now. Well, first let me stop the recording.